6B is a weak acid and another weak acid. So rather than knowing one thing is strong and totally ionizes, so we ignore the other, we do have two things that ionize and trying to think about how they can impact one another. But what we should notice on this is some differences in molarities. That's important, but the more important fact here is our Ka is 0.0006 versus 0.0000003. That's over 20,000 times higher, or about 20,000 times higher. So in terms of ionization, it's going to be much more significant. So when we do our math, we focus only on the stronger one. On the previous, we focused only on the strong and ignored the weak, unless we were trying to think about that conceptually. And if you skipped that video, note that at the end of it, there's some explanation of great multiple choice concepts. Same idea here, though. We are thinking about the stronger, ignoring the weaker. We've got our K, we've got X squared, we've got our molarity. We solve for X. The negative log of that is our pH. One thing I didn't account for on the last one was the fact that there's already some hydrogen ion, or they're both in solution together. And I'm going to show how that looks here. The weaker acid, and we've looked previously at the HClO, if it was just in water, and seen its pH and how much it ionizes. But since it is now in with another acid that also produces hydrogen, we have a molarity for it that does decrease, but there's already this amount of hydrogen ion. And hopefully that number looks familiar. It is how much hydrogen ion did the stronger of the weak acids produce? So there's already some of that in there, and then we ionize a little bit more. So in this case, we do have a kind of a Le Chatelier's principle, a common ion effect, and then we've got our X here. So we could do X squared over the molarity and solve for X. That would give us a small number, very similar to what we got on the previous problem. I think it was in number 4 related to HClO. But here, we would have to do the quadratic to get the true answer. And if we got that true answer, we would see that because there's another acid in there, very, very, very little of my HClO ionizes. So in terms of sig figs, it would be 0.000002 in terms of how much more hydrogen ion produces. And we see that that doesn't change our pH at all. It is the same number, the same sig figs, the same pH once we get to our final rounding of looking at just the stronger one compared to the stronger and the weaker, even when it's a combination of weak.